Welcome back to your Algebra 2 3.4 lesson. Let's finish up those examples. So we've already done example 1. Let's move on to example 2. This is the very fast forward version of this. Alright, we're going to solve the system. And we've got x plus y plus z equals 3, so that's equation 1. Equation 2 is 4x plus 4y plus 4z equals 7, and then 3x minus y plus 2z equals 5. And so the way I label them or keep track of them is I put the numbers in little circles so that I don't accidentally think they're a coefficient. So I would label the first one with the 1 in a circle, the second one with the 2 in a circle, and the third one with the 3 in a circle. All right, so the first thing we do is pick a variable to eliminate. So I look, the first thing I see is a plain x, so I go, excellent. I am going to try and get rid of that x. And so I decide I'm going to multiply equation 1 by -4 and add it to equation 2. Alright, but when you multiply equation 1 by -4 and add the result to equation 2, you obtain a false equation. Let's look. You get -4x minus 4y minus 4z equals -12, because when you multiply by -4, you have to do it to everything. Equation 2 doesn't change, so you have 4x plus 4y plus 4z equals 7. So when you go to add, you go, okay, great. My x's eliminate. -4x plus 4x is 0. But well, -4y plus 4y equals 0. Maybe I'll be left with some z's. -4z plus 4z is 0. And so for your new equation 1, you get 0 equals -12 plus 7 is -5. So that is a false equation. That is never true. 0 does not equal -5, so you have no solution. So your answer there is no solution. Alright, for example 3, we're going to solve the system. We've got x plus y plus z equals 4. It's always good to have an equation like that with all kinds of coefficients of 1, so we're going to make it easier. And then we have x plus y minus z equals 4. And then we've got 3x plus 3y plus z equals 12. So label them 1, 2, and 3 in little circles. And I look and I go, well, x and y would be easy to get rid of, but come on, z, I've got a plus z in equation 1 and a minus z in equation 2. I'm going to get rid of z. And I'm just going to add equation 1 and equation 2 together, and that will get rid of z. Alright, so we're going to rewrite the system as a linear system in 2 variables, and we're able to do that just by adding equation 1 and 2. So I've got them written there. And let's see, x plus x is 2x, y plus y is 2y, z plus -z zeroes out, so we've eliminated z. Excellent, that's what we wanted to do, and that equals 8. So we've got a new equation 1. And remember, I tend to write a little star in 1 and put that in the circle. That way I know it's not the original equation 1, okay, but I know it's my first starred equation, my first new equation. Alright, so I need to get another, I need to add 2 different equations together and eliminate z again. It's going to be real easy if I add 2 and 3 together. I could do 1 and 3, but then I'd have to multiply by a -1. I don't want to have to multiply by anything if I can avoid it. So I'm going to add 2 and 3 together. I've already added 1 and 2, so I can't do that again. Wouldn't be productive. I need to do 1 and 3. So, oh, excuse me, I said 1 and 3. I don't want to do 1 and 3 because then I'd have to multiply by a negative so that I get -z and then positive z. I'm going to add 2 and 3 just because I have minus z in equation 2 and plus z in equation 3. Okay, so here's equation 2, x plus y minus z equals 4. I'm going to add that to equation 3. So 3x plus 3y plus z equals 12. And I add straight down my columns there. X plus 3x is 4x, y plus 3y is 4y, and then 4 plus 12 is 16. The -z plus z zeroes out, which is great because that's what we wanted. So I put a little star and a 2 and put a circle around it. Now I'm going to work with my 2 star equations, my 2 new equations, to get rid of either x or y. Okay, so I'm going to solve the new linear system for both of its variables. So let's see. I am going to try to get rid of the x's, so I'm going to multiply my new equation 1 by -2 so that I get -4x. Alright, so I multiply everything in the new equation 1 together and not together, and multiply everything in the new equation 1 by -2. And that gives me -4x minus 4y equals -16. And I'm going to add that to the new equation 2. The 4x plus 4y equals 16. Okay, so I go to add, -4x plus 4x zeroes out, which is what I wanted, so that's awesome. And then -4y plus 4y, that adds up to 0. Okay, so I get 0 equals -16 plus 16 is 0. Alright, so you obtain an identity, 0 equals 0, an equation that's always true. This means the system has infinitely many solutions. And back when we had just two variables, we just left it as infinitely many solutions. This time, we're actually going to come up with expressions for the 3 variables. We're going to let x be x, and we're going to solve one of the new equations, the ones just in terms of x and y, for y in terms of x, and then we'll figure out what z would have to equal. Okay, so describe the solution of the system. One way to do this is to divide the new equation by 2 to get x plus y equals 4, okay, because we originally had 2x plus 2y equals 8. So we divide everything by 2, you get x plus y equals 4, and then just solve for y. And so you get y equals -x plus 4. So we're going to let x be x, and y will be -x plus 4. Then we're going to substitute those into the original equation 1. The original equation 1 was x plus y plus z equals 4. So if we substitute in, we leave x as x, and then we do -x plus 4 for y, we get x plus -x, well that's 0, plus 4, plus z equals 4. Subtract 4 from both sides and you get z equals 0. So any ordered triple of the form x -x plus 4, 0 is a solution to the system. So if I substituted in 1 for x, then 1 for x, -1 plus 4, so 3 for y, and 0 is the solution of the system. If I plugged in 10 for x, 10, -10 plus 4 is -6, and then 0, so 10, -6, 0 is also a solution of the system. Any triple of that form is a solution to the system. Okay, so let's look at a word problem. And in this word problem, we're actually going to be able to use substitution instead of elimination, and that just means that you're able to start off just a little bit different way. We could use elimination on this one, but it's good to see a different way to do it. The marketing department of a company has a budget of $30,000 for advertising. A television ad costs $1,000, a radio ad costs $200, and a newspaper ad costs $500. The department wants to run 60 ads per month, so we're talking about a monthly budget of $30,000, and have as many radio ads as television and newspaper ads combined. How many of each type of ad should the department run each month? All right, so let's think of the verbal models for the situation. If you add TV ads plus radio ads plus newspaper ads, that's going to equal the total number of ads. So we'll be able to do that because we know the total is 60, and we can come up with variable expressions for TV ads, radio ads, and newspaper ads. All right, each TV ad is going to take up $1,000. Each radio ad is going to take up $200, and each newspaper ad is going to cost $500. So if we multiply the number of each kind of ad by the amount it costs, add those together, you'll get the monthly budget. The other thing we know is that the number of radio ads equals the number of TV ads plus the newspaper ads. They gave us that comparison statement in our problem. So let's let x be the number of TV ads, y be the number of radio ads, and z be the number of newspaper ads, and we can write our equations algebraically. So we're going to have x plus y plus z equals 60, okay, because it's the total number of ads that we have. Now let's do our budget equation. So 1,000 times x plus 200 times y plus 500 times z equals 30,000. And then our comparison equation, equation 3, where y, the number of radio ads, equals the sum of the TV ads and the newspaper ads, so y equals x plus z. Now, we could transform that third equation to be negative x plus y minus z equals 0, and then use elimination to get started. But since we already have y solved in terms of x plus z, why not use substitution? So what we're going to do is we're going to take that x plus z and we're going to substitute that value in for y, replace y with x plus z in both equation 1 and equation 2. So we're going to rewrite the system in step 2 as a linear system in 2 variables by substituting x plus z for y in equations 1 and 2. So for equation 1, instead of x plus y plus z equals 60, we're going to have x plus z plus z equals 60 because we've substituted x plus z for y. And so we're going to get a new equation 1, which again I would call star 1, put a circle around it. We're going to have 2x, because x plus x is 2x, plus 2z, because z plus z is 2z, equals 60. Okay, now we're going to go through this process with equation 2. So equation 2, we have 1000x plus 200y plus 500z equals 30,000. We're going to replace y with x plus z. We're going to substitute x plus z for y. So we've got 1000x plus 200 times the sum x plus z plus 500z equals 30,000. Okay, so we would have 1000x plus 200x is 1200x. 200z plus 500z is 700z, and that equals 30,000. So that's new equation 2. And so I call that star 2 and put a circle around it. Okay, so now we're going to work with our 2 new equations, our 2 star equations. Solve the linear system in 2 variables from step 3. So solve your 2 new equations or the starred equations if you use the symbols I like to use. All right, so we're going to add negative 600 times new equation 1 to add it to new equation 2. That way we get opposites for our coefficients. We want negative 1200 and 1200. So that gives me negative 1200x minus 1200z equals negative 36,000. I'm going to add to that my new equation 2. So 1200x plus 700x equals 30,000. The x's eliminate, which is what we wanted. Negative 1200z plus 700z is negative 500z. Negative 36,000 plus 30,000 is negative 6,000. So now we're going to divide by negative 500 and we get z equals 12. All right, so from here we just start working back up. We plug in 12 into either one of the 2 starred or new equations. So we're going to substitute into either new equation 1 or 2 to find x. Go ahead and do that. I substituted, let me look at my work here. I substituted into new equation 1 because it was so much easier to work with the 2x plus 2z equals 60. So go ahead and do that. Pause, and then we'll come back and I'll talk through the steps, and you can check your work as I do that. So plug z equals 12 into 2x plus 2z equals 60. Okay, so when we substitute in 12 for z, we get 2x plus 24, because 2 times 12 is 24, equals 60. We subtract 24 from both sides, and we get 2x equals 36. Divide both sides by 2, and we get x equals 18. So now what you want to do is you want to take x equals 18 and z equals 12 and plug it into any one of the original equations. Equation 3 is probably the easiest. So if you do that, you're going to have y equals x plus z, so y equals 18 plus 12, and so y equals 30. Okay? All right, so what does that mean? That means that since the solution is 18, 30, 12, the department should run 18 TV ads, 30 radio ads, and 12 newspaper ads each month. Okay, guys, you need to do the problems to try on your own right now. This process is a little slippery, and so if you don't try it now, it may slip right out of your mind before you try it. Be very careful about sign errors and make sure that you do your arithmetic correctly. One little mistake can really mess up the whole process. So it's time to really focus and be super duper careful about not making careless mistakes. Okay, guys, Do the problems to try on your own, and I will see you in class next time where we will go over the problems to try on your own, and then you will get started on your rounds. Have a great day. I'll see you soon.